Go ahead, Andrew. Thank you.
Could I just ask, hi, Edward Carmey from H3 Biomedicine. Could I ask Dr. Wu about combination plans and strategies at Agios, and whether any of these hypotheses that Dr. Kaelin laid out regarding synthetic lethality are being prosecuted or being planned to be prosecuted in the setting of cholangiocarcinoma. And then, just stepping a step back from those types of very rational approaches and thinking more generally about drug-drug combinations, how well tolerated AG120 is allows us clinicians to get very excited about its combinability. What other drugs, even those with completely separate mechanisms of action, are you thinking about in terms of drug-drug combinations?
Well, thank you for your question. As you can see, these are the questions in our daily life in thinking of how what's the next step. So there are many approaches to combination strategy. One is the rational coming from screening, and the other are either you have a targeted novel combination, or you take another approach is being combined with chemo, given that AG120 is fairly mild, can be considered a gentleman in terms of the small molecule inhibitors. So as I mentioned, that we are actively looking into all these expression profiling and genomic profiling and any other possible factors in correlate with the response to look at any factors that would point out to the direction of a combination strategy that will give us high possibility of success in the next step. And we're actively doing research, and hopefully some of these will come out in the future conferences. So Susan is the medical monitor of this drug. So you want to add on anything about? Okay. So sorry, I cannot give you specifics because we're still mining the data. At this point, we haven't come out with a dominant mechanism of resistance. So,
Andrew?
This question is for Bill and Bin. I think it's very clear 2-HG has served as a very good pharmacodynamic marker for all the trials. But it's also clear it doesn't seem to actually predict as a very good surrogate for clinical outcome. I think we have heard a lot of the post-treatment biopsy data. But clearly, we all acknowledge that relying on the post-treatment biopsy, perhaps it's not going to fly on a bigger scale. So I'm curious, whether it will be even feasible to think about whether there will be any circulating biomarker short of 2-HG that we actually potentially can exploit as a potential surrogate marker for clinical efficacy.
I think it's a good question. I mean, I think we all would agree that we're blessed to have it as a PD marker. And my assumption would be that downregulation of 2-HG is necessary, but not necessarily sufficient for a therapeutic benefit. And I think we have to start to understand the contextual determinants of why some cancers, and even within a cancer type, why some patients respond and some do not. And so for example, there's conjecture, and I underline conjecture, that within the glioma community, maybe the people who have truly low-grade glioma might behave differently than patients who have acquired one or two more cooperating mutations, might have a somewhat more aggressive natural history. But I think we certainly need these biomarkers, and maybe in time we'll be able to detect them in the form of maybe circulating mutations, where we'll be able to profile the patients readily, and maybe that will help.
So I think Dr. Bill Kaelin said it. So the 2-HG to us is a pharmacodynamic target engagement marker. It's necessary but not sufficient, not only in the case of solid tumor, actually in our heme trial, it's the same situation. So And to comment to your circulating biomarker, that's another area of investigation. So we actually implemented in our phase 3 trial.
Ben.
So I guess I'm going to ask about mechanisms of resistance, either those that you have already observed or can anticipate. And I'm particularly interested in glioma, where it wasn't entirely clear to me whether it's a driver and whether just mutating the mutated allele or loss of that allele would be sufficient to give you resistance.
Yeah, so I think there's a growing fear that I share based on some of our unpublished work that in glioma, I think it's categorically was a driver. Genetics strongly says that, and we've recently been able to generate tumors in mice driven in part by mutant IDH. But we're really starting to worry that unlike the situation in leukemia, that it's almost a hit and run mechanism, that you've caused these epigenetic changes that have put in place a feed forward loop. Now, that doesn't mean to say there couldn't be some benefits of over time blocking 2HG, but at least in laboratory time scale, it looks like it's hit and run, at least in our models. And it's been said all models are wrong, but some are useful. So I don't know whether these are the best models, but in the current laboratory models, it's starting to look like a hit and run mechanism in glioma.
David Bates, University of Nottingham Cancer Centre. I've got a question for Lewis. The two parts, really. The categorization into those 4 categories. It's interesting that the IDH and the FGF receptor separate out in terms of that. But is that because they're generally a metabolic versus a kinase types with a DNA with a DNA repair mechanism in the middle, and that the fact that they fall into those regions are indications of that they are subsets of subsets, and that actually that getting some indication on phosphoproteomics or on RNA splicing or something else would help you to break that up into even smaller identifiable groups that might then be amenable to direct treatment. And the second point is the stromal component might be really important, and excluding high stromal components may actually exclude half of the interesting data, because it's the stromal cells that are driving a lot of the resistance or a lot of the progression of the tumors. So is it possible to go back and go, right, well, don't worry about the DNA for the ones that have got high stroma, but the RNA is critical. So finally, can you do a splicing analysis on the RNA instead of just an expression analysis?
Great questions. So I think you're right with the first question. The way these analyses are done is for people to do an unsupervised clustering to see what number of clusters, in a sense, gives you the best fit. And so they'll test out doing 2, 3, 4, 5, 6, 7 through 8 or 10 and see which, in a sense, gives you the least. If you think about it in energy, and sort of in terms of the energy of a reaction, it goes to the least energy, in a sense, it gives you the best discrimination between subtypes. But within the subtypes, typically you can find additional subtypes, and clearly what we are seeing here is that it looks as though the FGFs will group, for example, with the BAP1s for some reason. But that's not to say that the FGFs, and the BAP1s should be targeted by the same agents. And I think that it's partly due to the fact that we are wanting to come to sort of a reasonable and most discriminatory subset of clusters is really what that does. I think from the standpoint of your second question, that was an ongoing, at least at the beginning, a debate with TCGA, and I think they were limited really by the technology at the time. Okay. So for pancreatic adenocarcinoma, for example, they were already working very hard on pancreatic adenocarcinoma, and that project took a long time because they were basically trying to use analytical methods to separate out the signals from the from the tumor from the stroma, and it was not trivial. So I think when we came along with cholangiocarcinoma, they said no, we aren't going there. we'll have to leave it for another day. But I think that clearly as a community here, we have to address that, and we need to, I think, develop the joint projects necessary to do that.
And the
So we'll-
splicing?
Oh, sorry.
And splicing? Can
Yeah,
you
so
look
I
at-
think we can do the splicing analysis. I think there was some limited analysis done with many of the projects, but really not a complete analysis. So there's really, again, it's a treasure trove of information that's out there for future mining.
So we'll take these last two questions at the mic, and then we will try to preserve the sanctity of the break.
So I had a question for Bill. I was wondering if you have any comments on the alternative hypothesis for the sensitivity of IDH mutant cells to DNA damage or PARP inhibitors, this apparent inhibition of Jumanji proteins by 2HG, and an implication of one of the Jumanji proteins in homologous repair.
That was my question as well, so 2 for 1.
Yeah, I don't think they're mutually exclusive. We can do a variety of manipulations that I didn't go into here to restore, for example, glutamate levels, to restore glutathione. We can rescue many of these phenotypes. But that doesn't mean that there isn't some contribution from inhibiting some other 2OG-dependent enzyme, including maybe a Jumanji C protein.
I just had a general question, if I can just follow that up, is that do you think that there's use in efforts to kind of determine the inhibitory constant for different alpha-ketoglutarate utilizing enzymes to kind of get hunches? And do you have any sense for the BCATs compared to some of the Jumanjis, which have been profiled by Schofield?
Yeah, so we're starting to do that, but of course, as you appreciate, yes, it can give you sort of a list of suspects and generate some hypotheses, but there could be some enzyme that's exquisitely sensitive to 2HG, but at least with respect to causing transformation, it might be irrelevant. And so before we get into your level of granularity, I think it's most important to figure out which of these enzymes are causing the cancer and which are bystanders, and then secondarily to get into your question of, okay, but which of the bystanders are responsible for example, the DNA damage phenotype.
All right, we would like to thank all of the speakers for the session, and we will now have about a 15-minute break.